Welcome to the third video in Lesson 1, Patterns in Division. Here we're going to continue our work with creating divisibility rules. So we'll start by shading in all of the multiples of 4. So that would include all of these yellow colored blocks here. So what do you notice about these numbers? Well, if you look at the last digit, you might notice that they're all even. But having said that, not all even numbers here are shaded. 2, for example, is not shaded, or 14, and so on. But that is the only pattern I notice right now. And when we look at the divisibility rule, the fact that it's even is very important, because the rule says if the number can divide it by 2 twice, then it is divisible by 4. So let's have a look at an example. If I take 76 and divide that by 2, I get 38. Now because it ends in an 8, that can divide it by 2 again to be 19. And we don't actually need to figure out the second quotient, the answer of 19, because after we do division by 2 the first time, if the answer is even, we know it can be divided by 2 again, and if it's odd, we know it can't. But here I was able to divide by 2 twice, so that means 76 is divisible by 4. Now let's look at 90. If I divide 90 by 2, I get 45. Now if I try to divide 45 by 2, I can't do that because 5 is odd. Now I'm going to change this rule a bit to say that if the last 2 digits can be divided by 2 twice, then it's divisible by 4. Now that rule wouldn't make a difference for the above 2 examples of 76 and 90, seeing that they only had 2 digits, but if you had a large number like 568,732, well, this rule can come in handy. If we just focus on the last 2 digits, 32, we just got to see if that can be divided by 2 twice. So 32 divided by 2 is 16, and because 16 is even, then that certainly can be divided by 2 again, which happens to be 8. So that is divisible by 4. So you can see how using this rule can be useful, in particular for rather large numbers, instead of actually having to do the long division. So now let's see if we can find a divisibility rule for 8. Let's shade in all of the multiples of 8. That would include these numbers here. So do you notice anything about the colored yellow blocks here? Well, the only thing really notice is that they are all even. But again, there's lots of other even numbers that are not colored. So I can't come up with the rule saying that if it's even, it is divisible by 8. But again, being even is very important to the rule. So the divisibility rule for 8 states that if the number can be divided by 2 3 times, then it's divisible by 8. So for 4, we had to divide by 2 twice. So for 8, you just got to divide it again by 2. So let's look at the number 88. So already knowing my multiplication facts, I know this is divisible by 8, but let's practice the rule. 88 divided by 2 is 44, so it can be divided by 2 once. 44 divided by 2 is 22, so it can be divided by 2 twice. So I just established that this is also divisible by 4. Now if I do it a third time, 22 divided by 2 is 11. So I was able to divide 88 by 2 3 times, meaning 88 is indeed divisible by 8. So that's how this rule works. Now I'm going to make a little change like I did for the last divisibility rule for 4 and state that if the last 3 digits can be divided by 2 3 times, then is divisible by 8. So again, that change wouldn't make much of a difference if you're looking at a number like 88, but if you have 60,722, it is a lot easier just to focus on the last 3 digits than it is the whole number. So let's try dividing this by 2 3 times. So 722 divided by 2 is 361. So I can stop right away because 361 is odd. I can't divide that by 2 again. So this is not divisible by 8. I can also say it's not divisible by 4 either, because I couldn't divide by 2 twice. Now I want to go over a method of organizing data into groups using a Venn diagram. Now you may have worked with these previously, but I still want to review. So here I have 2 groups, say A and B. Now if A and B have something in common, then the elements would be placed in the middle here. Now for those elements that belong to set A but not B, they will go on the left. And the elements that are in B but not A will go on the right. And if there's elements that have nothing in common with A or B, they will go outside the circles. So let's look at an example. So here we have to place each number into the Venn diagram. So I got my circles labeled on the left. In that circle, you put all the numbers that are divisible by 4. And on the right, all the numbers that are divisible by 8. So let's start with 100. Let's start dividing by 2 to see if it's divisible by 4 or 8. Now 100 can be divided by 2, so that's 50, so it can be divided by 2 once. It can be divided by 2 twice, so it's divisible by 4. Let's see if it's divisible by 8. Can I do 25 divided by 2? No. So now since this is divisible by 4, but not 8, that will go in this section of the Venn diagram. Now let's look at 24. 24 divided by 2 is 12. I can divide that by 2 again to give 6. And I can divide it by 2 a third time, meaning it's divisible by 4, because I divided by 2 twice, but also divisible by 8. So because it's both, this number will go in the center, the overlapping area. Now for 412, I can divide that by 2 once. I can divide it by 2 again, but can I divide it by 2 a third time? No. So this number is divisible by 4, but not 8. Now what about 58? I can divide that by 2 to get 29. Can I divide that by 2 again? No. So this is not divisible by 4, and it's not divisible by 8 either. So this number will go outside the circles. Now lastly, we have 9,208. We just need to focus on really the last 3 digits if we're trying to see if it's divisible by 8. So I can divide it by 2 once, and I can divide it by 2 twice, so it's divisible by 4. Can we do it again a third time? Yes, we can, because it's 52, which is even. So this number is divisible by 4 and 8. So that's another one that goes in the center overlapping area. So that's how you can organize data into a Venn diagram. Well, that is the end of this lesson. Be sure to complete all of the activities before moving on.